Now, if you've taken any other programming language ever, you already know what a loop is. The syntax for this is a little bit different than it was in Python, but the idea is the same. You have while loops, and then you can have for loops. Pretty much every language that's worth talking about anymore has a while and a for loop. And some languages, including this one, have a do loop as well. Python did not, because there's honestly nothing you can do with a do loop that you cannot do with a while loop. But it does make some syntax easier, so it's kind of nice that it exists. We're going to talk about when you would want to use it. And then file I/O differs for every programming language and every library that you use. File I/O in this language is kind of neat because once you get the file open, like if you opened a file and it was assigned into a variable called f, then writing to it is as easy as doing this. That would write that out as text. Now, if you didn't want it written as text, you'd have to do it as something else. If you wanted it written out as a binary value rather than a string, you have to do something else. But I think what we're going to do is just do string output and string input, because we can store numbers and read numbers in just as easily, right? That'll write out the number 1 to the file. And then it could be read doing the other thing, right? If you're going to read that variable into X, right, it's as easy as doing that. All we're doing is we're replacing CIN and COUT with the name of the file handle, the file variable, right? That's how you read in to X. If you're using, no, that's not how you read it. That's how you read in, right? You just replace CIN with your file handle. Same thing, if you're going to write a value out, you replace that with a file handle. I think I'll delete those notes for now because we're going to hit them in earnest at a later point. So, plus plus is the increment operator. So, it was on the exam, and it's part of Chapter 5, which the exam wasn't supposed to cover. Now I'm feeling even better about taking that question off the exam. It just adds 1 to a variable. It's the same as x equals x plus 1. It could be used as a prefix or a postfix. If it's a prefix, it's the first thing that happens in the expression. If it's a postfix, it's the last thing that happens in the expression. The entire expression is evaluated and then 1 is added to it. Just like you have increment, you have decrement. Minus minus instead of plus plus. So val minus minus is the same as val equals val minus 1. It used to be that putting minus minus in front of the variable, even if it was on its own line, was like a nanosecond faster than putting it after the variable. I would expect that by now these compilers, which they spend enormous amounts of time on optimizing to produce the fastest executables possible, should not do that anymore. Because if that line is on its own, with nothing else, right? If I do int x is equal to 3 and then x plus plus, after that x is going to equal 4. If I did it with a prefix notation, x is equal to 3 plus plus x, x is still going to equal 4. But it used to be that if you did this, it only accessed a memory address twice in order to read the value and then to write it back out. And if you did it this way, for some reason, it took 3 memory accesses in order to do it. And so the savvy coder would do it that way. Just put the plus plus in front. Like I said, I doubt it means I doubt that that's the case anymore. However, one of the examples that we do in C# is to try to prove whether it's faster or slower, and in C# it actually is faster to always use the prefix operator if you can. So if you feel like getting into the habit of always writing plus plus x rather than x plus plus, great, but I can't help it. I mean, the name of the language is C++, it's not plus plus x, so I go for that. Oh, by the way, you know, there's the other language, C#, that's Microsoft's own language. It's similar to C++, but it's different. Well, how did they get that sharp symbol? Well, if you had two plus pluses in a row, can you kind of see how that makes a sharp? That plus that, kind of making that, if you squished all of the spaces together. So, you know, it was twice as good as C++. Slightly clever. All right. No one's impressed. Let's go on. So, as I mentioned, the operators can be used in prefix mode or postfix mode. In prefix mode, the operator increments and then returns the value of the variable. So the variable is changed before it is used. In postfix mode, the operator returns the value and then it is changed. Maybe that's why it took 3 accesses, because it has to return the value, 3 memory hits, and then update it. So, num and val are both equal to 12. No, num is not equal to anything yet, but val is equal to 12. Write out val plus plus. Well, this is suffix notation. Postfix, excuse me, they were calling it postfix. So that's postfix notation, meaning what? That val gets used before it is incremented. So it would write out 12, and then val gets one added to it, 13. On the next one, we use the prefix notation, so the plus plus happens first, and then val is written out. So val is set to 14, and then it is displayed. In the same business with subtraction. So yeah, that's pretty blatantly covered in Chapter 5, not 4, so it should not have been on the exam. You can use them in expressions, like that. Now to me that looks pretty wild. But C programmers in particular are very fond of writing incredibly tight little loops using things that kind of look like that. But what would this do? Which does happen before the expression is evaluated? The change to num1 or the change to num2?
num2.
Yeah, so this one would get updated first. And then that would be added to that one and copy the result, and then num1 would get incremented by 1. And it says, must be applied to something that has a location in memory. You can't do this, right? If num1 and num2 were 10, then the answer to that is 20. Plus plus does not change it to 21. Plus 1 would. But what plus plus is supposed to do is take whatever's before it, add 1 to it, and store it back into that variable. Well, that's not a variable, so it can't store it back anywhere. So that's just illegal syntax. It can be used in relational expressions. You just have to remember that the comparison will be different based on whether it's prefix or postfix. The while loop. While this expression is true, continue to repeat the body. Statement can be a single line of code, or it can be a block of code with more than 1 line if you put them inside braces. If you put a semicolon here, it makes an infinite loop. Because what that means is while x is less than 10, do this, and then maybe we have some code, right? You know, C out x or something like that. If we did it like this, with the semicolon there, that's how it turns into. This and this are functionally equivalent. So while x is less than 10, do absolutely nothing. Well, nothing ever changes the value of x then. So if it was true once, it's going to be true forever. So it's an infinite loop. So you never want to put a semicolon there, just like you never want to put a semicolon there on an if statement. If you put a semicolon on the if statement, it disables it so that the line that follows it always happens no matter what. Pretty much any time you have a curly brace, you don't want to put a semicolon on the line above it. Now, in this particular case, if you had left out the curly braces, right, then it not quite as bold, but anyways, we started indenting, and so the line above it should not have a semicolon in front of it. Now, I get why people make that mistake because they had to put colons in that particular spot in Fortran and in Python. So the loop is a control structure that causes a statement or a series of statements, a block of statements, to repeat while the expression performs the statement. The expression is evaluated. If it's true, the statement is executed, and then the expression is reevaluated. And whenever it finally becomes false, it drops out of the loop. It no longer performs a statement. Like this. Is that expression true? Yeah, sure is. Do my statements. Okay, we've done my statements. Check the expression again. Is it still true? Nah, so we fall out of it. While number is less than or equal to 5. That's our test expression. We're going to keep doing this as long as x is less than or equal to 5. Now, something that may be slightly subtle. I don't get too many people who think this, but some people do. If we did this, x is equal to 1, while x is less than 5, and then we did x equals x plus 5 here, and then we see it out. See out at it? When I say it keeps repeating this as long as x is less than 5, doesn't mean that, oh, at the very instant x becomes greater than 5, it's going to get kicked out of it. No, it's going to repeat the entire block of code before it's checked again. So it's not like x becomes 10 there and, oops, that was no longer less than 5, and it skips that. Once it's in here, it's got to do all of it before it can be checked again. The only exception is that if there's some kind of if statement with a break in here, right? If you put a break in there, break means exit the loop early. So it would add 5 to x, and then it would immediately bail, and so this line of code would never be executed. I think the Java compiler would even call that a syntax error because it has unreachable code. C++ probably warns you, but it doesn't call it a syntax error. But you can do things conditionally, like if x is, equal to 7, whatever, break. You could do that. That gives you 2 exit conditions, right? It will exit when x is no longer less than or equal to 5, but also in the middle of the body, if x is equal to 7, it will bail. Now, writing things with 2 exit conditions, 2 exit states, is not maybe the best thing. Typically, the recommendation is to make only one way out of the loop, but there are some exceptions. It's not necessarily a bad, no, I'm not going to even get into the exceptions. Let's just keep chugging along. So here's a block of code subordinate to the while, right? It's 2 lines of code. So both lines have to be executed before the expression is reevaluated. If the first one changed the value of number and this expression was no longer true, too bad, it still does that. Then it checks it again and then it falls out. It is what's known as a pretest loop. The fact that it's calling it out as being a pretest loop implies that there's a post-test loop as well. What does pretest mean? It means that this expression is evaluated before the code comes in here and does this. And so if this is true, it does it, but if this is false, hello is not even printed out one time. And that's the case. Number is equal to 6 while number is less than or equal to 5. Well, that's not true. It's just like that was written with an if. If it was if, it wouldn't do this. Same thing with while. Pretest means do the test first and then conditionally perform the block of code. Now, what if there was a way to get that test to be post post-test expression. You can write code like that in this language. You couldn't in Python, but on a vast number of languages that are generally based on the C syntax, including Java and C# and JavaScript, you could do it. But you put the keyword do there in front of it. To me, kind of seems unnecessary. It seems to me like it ought to work just as well if you did that. But what do I know? We have to put the word do there, and we have to put a semicolon there to turn it into a postfix loop. If we have a postfix loop in it, in other words, a do loop, x is equal to 6, print hello. There's no choice. It has to print hello. There's nothing that's going to kick it out. There's nothing preventing it from getting in here. There's no gatekeeper. So it prints hello, then it adds 1 to number, so x becomes 7, and then it checks. Is x, I keep calling it x, sorry, number, less than 5, less than or equal to 5? No, that's not the case. So it would print out hello. It enters the body no matter what if it's a post-test. If it's a pre-test, entering the body is conditional based on whether that expression is true or not. So in general, pretest loops. The body of the loop is executed 0 or more times based on the expression. Post-test loop. The body of the loop is always executed at least 1 time with the expression tested at the bottom, at the end of the block. There's a third kind of loop besides while and do. So pretest loops are while loops. Post-test loops are do loops or do while. I'm just going to call it a do loop because that's what it starts with. So do loops are post-test. There's one more form of pretest loop, which is a for loop. So here's an example of a pretest loop. X is equal to 3 while x is less than or equal to 10. See out x plus plus. Now, since I want both of those statements to be subordinate to the while header, better put them like that. That's a pretest loop. If this value was set to something that prevented it from entering the loop, like 30, then this code would not perform, which is why up here I said the body of the loop is executed 0 or more times based on the expression. If x is 30, it can't be less than 10, it doesn't do it. The other syntax, the do loop, x is equal to 3, do this stuff, do some couts, increment x, and then evaluate it while x is less than or equal to 10. It does this no matter what, whether x is 3 or 3 billion. It's always going to print out at least one thing. Now, if it's a valid value, the output's going to be the exact same thing, right? It's going to print 3, 4, 5, 6, 7, 8, 9, 10 here, and it's going to print 3, 4, 5, 6, 7, 8, 9, 10 here. But if x got changed to 3 billion, it would not print anything here, and it would print 3 billion and then stop. What if you were using a language without a post-test loop, like Python? You can simulate it. You just do a while true loop. While this is true, set x is equal to 3. While true, do something. See out x, then add 1 to x, and then if x is greater than 10, break. Break means exit the loop. So this code and this code are functionally identical. They perform in exactly the same way in all circumstances. And I guess that's why the inventor of Python decided that you didn't need a do loop, because you could simulate it with a while loop and a break. The syntax for this is a little bit cleaner, right? Maybe. But if you use Python often enough, you kind of stop even thinking about do loops, since you don't have them available to you. Do I need to keep that up while people are typing? Yeah. Watch out for infinite loops. The loop must contain code to make the expression become false. If we had this code here, or a while loop, but we never change the value of x, then as long as it enters it in the first place, it's going to repeat infinitely until the program is terminated, right? Until you click the X or turn the machine off or something. So here we go. Number is equal to 1, while the number is less than or equal to 5. Print out hello, but nothing ever changes the value of it, so this statement never becomes false, so it keeps repeating it endlessly. Using the while loop for input validation. This is actually worth us typing in some code. You can use loops to validate input. What does that mean? Force them to enter a good value. Do not let the loop exit until they've given you a valid value. What do I mean? If we want them to enter a guess between 1 and 100, we're not going to let them get away with typing a 200. We're going to use a loop that does not let them exit the loop until they enter a valid value. I believe we're on lecture J. You're correct, it's I. We're the class ahead, they're yeah, you're right. Okay. Lecture I. The folks who didn't have their exam last week, today would have been lecture J. But you did, so it's I. Thank you for catching that. All right. Yield boilerplate time. Stupid trivia. Ye old shop. It's not pronounced ye. It's just that that character, which is called Thorn, didn't really look like a Y. It looked very close to a Y, and it was pronounced TH. So it's still the old shop. There. Now you know something to brag to your fellow D&D players about. Okay, let's go grab our boilerplate. Add our Solution Explorer. Add a source file. New item. Lecture I.cpp. Paste. Alrighty. So, what are we going to do? We're going to write a loop that does not let the code exit until they've entered a good value. So this is not lecture G, it's lecture I, according to my boilerplate. I don't care if you have that C out there. Okay, so what are we going to do? We're going to ask them to type in cookie. Or now, let's just ask them to type in 3. And if they type in anything other than 3, it's an error. So there's two ways of accomplishing that. One is with a post-test loop, and the other is with a pretest loop and a priming read, and I guess there's a third way of doing it, which is a pretest loop with a break. But this code, this book, unlike some books I've taught from, do not demonstrate using a while true break to simulate a post-test loop. So let's just go ahead and do it without using the pretest loop. We'll implement it two different ways, but we are going to need a variable, int x. Now let's do something. Do cout, enter the number 3, and hit return, right? Hit enter. Or type 3 and then hit enter. Space, space, end quote. All right, and then cin greater than x, and then the end of our do loop after the closing brace is going to be while parentheses x not equal to 3. And so I'm going to run it. If I type in 3, it's going to exit immediately because this condition will be false. And when I say exit immediately, it's going to drop out of the loop, not force them to retype anything. Type 3 and hit enter. So if I type 3, game over, it worked. If I type in something other than 3, like 4, it tells me again, type 3 and hit enter. It doesn't print out a warning message. I'm not really digging that. I'd like for it to print out, you know, you didn't type 3 or you didn't type an even number or whatever the condition is. But that's the simplest form right there. A little do loop that asks a question and then they type something in. So that's one way of doing it. Let's do it a little bit better. And we can use a pretest loop to do it a little bit better, but it requires one of two things. One is either a break statement inside the loop, or it requires a priming read. What's a priming read? If you remember from your fundamentals class, if you took fundamentals, it's when you have an input statement both before the loop and inside it. Like this. Cout, less than quote, enter 5 and hit enter. Okay, type 5 and hit enter. Colon, space, end quote, semicolon. Now we're going to let them type it in. So cin greater than x, and then while x is not equal to 5, in parentheses, that means they typed the wrong thing. So curly brace, let's yell at them. Cout, less than, I told you to type 5, exclamation point. Now I'm going to get rid of the exclamation point because they'd probably try to type that. \n, end quote, semicolon. Now we have to, I'm going to make a mistake, a rookie mistake. I'm not going to ask for the input again. While x is greater than or not equal to 5, I told you to type 5, but I don't give them a second chance to type it. So if they get it wrong the first time, it goes into an infinite loop. Let's get this first one correct. I'm just going to type in 3 there. That's correct. But now I'm going to get it wrong here, and it goes in infinite loop mode because I never allowed the value of x to be changed. So I need to tell them again, or cout, type 5 and hit enter, colon, space, end quote, semicolon, and then read it in again. So this is a priming read. This is the first read, and then inside the while loop, inside the error handling, is a second read, or a looped read. That's a way to handle it, and it's a little bit better than the do loop. Now the do loop could be modified with an if statement, right? We could double check right here and then print out an error message. But then we have the condition twice, right? We have an if statement that's checking to see if it's wrong, and then we have this here as well. But here's what it would look like if we wanted to make this loop better. so that it would print out an error message if they typed in something other than 3. We could go to this above this line, close brace while x not equal to 3 semicolon. Notice that you do have to put the semicolon there. Let's check. If parentheses x, can I type? If parentheses x not equal to 3, close parentheses, C out less than, I told you to type 3, \n, end quote, end semicolon. Now they both functionally behave the same way. There's absolutely no difference in the way these things behave. They're coded differently. One has 2 input statements, including the priming read, and one only has 1, but they are functionally the same. The advantage to coding it this way is that there's only one comparison. Right. Here we have this comparison repeated. The disadvantage of doing it this way is that the code complexity is a little bit more because we have some copy-pasted code here. We do a second bit of output and a second input, that's repeated. So we had some nested logic here with the expression duplicated here to do it as a post test. Here we don't have any nested ifs, but we had to use a priming read. And here's my preferred way of doing it, which is to kind of combine it so that we use a while loop, but we don't have a priming read. Instead, we're going to do while true. How does that work? Well, this expression is evaluated, and if it's true, then it enters a loop. Well, the word true means it's always going to enter the loop, no matter what. But if you're going to do that, there better be a break statement in there, or a return. So while parentheses, true, in parentheses, curly brace, let's tell them what we want them to do. Now type a 9 and hit enter, colon, space, end quote, semicolon, CIN greater than X, semicolon. But we better check to make sure it's correct. If X is not equal to 9, end quote, print out an error message, C out less than, quote, I told you to type 9, \n, end quote, semicolon. All right. Else break. I'm not liking the fact that we have an if-else, but the other way of wording it would still be almost functionally the same, so I'm going to go ahead and run with that. All right, it's kind of up to you which one makes more sense to you. All 3 of these now do functionally, according to what the user sees, the exact same. Why do I like this one myself? This is my preference, even though the book doesn't show it. This textbook, some others do. Because you don't have any duplicated code. The condition is not duplicated, as it was in the pretest loop immediately up, or in the post-test loop. And then there's no duplicated input. There's no priming read. So that's my preferred way of doing it. I am going to revise as to how I would actually probably do it. This way is just as good as the other one, but for some reason my brain likes to see it like this better. I would change this to, I deleted those lines, if x equals 9. It's a good value, so break. C out, I told you to type 9, \n, end quote, semicolon. I'm able to get away with leaving the else off because if it breaks, it skips this line and comes down here. And if it doesn't break, it's going to do that line anyways, regardless. It would not be incorrect to put an else That, if that's your preference, that would work, but it's not necessary. So if I'm coding for myself rather than coding to give examples in class, that's how I do it. So this is input validation using a pretest loop and a while true and a break. The book's not going to show it to you that way. I believe they're going to show you with a priming read. We will flip back to the PowerPoint and find out. Does anybody need me to come look and fix syntax errors? We all good? About time to take a break then, in my opinion. So these are all examples of input validation. I'll just add that as a comment up at the top. I'm not going to add any more commentary because they all three work. So you can pick which one. I may veer in all my future examples to doing it that way, even though that's not what the book shows. If you develop a different preference, that's fine. All right, so input validation, what is it? Inspecting the data to make sure it's valid. Now our check was pretty easy, right? Is it 3? It can be something else, right? Enter a number between 1 and 100. Well, then your expression would have to be a little bit more complicated, right? So C out, enter a number between 1 and 100. And it looks like, for some reason, my brain decided to do this with a priming read. So I guess I'm going to go with that. And CIN into X, despite what I just said about always using break. And then while X is less than 1 or X is greater than 100, that's one way to express it. There's two ways. You could use a not in there. Use a not and. While it's true, like that, print out an error message and then ask them again. Because if they typed in something less than 1 or greater than 100, it's no longer between the values. So let's print out an error message. Input must be between 1 and 100, \n, end quote, semicolon, and then do it again. I'm just going to copy these 2 lines and paste it rather than type them in again. I'm going to copy my priming read and its prompt, paste it and tab it. Like that. All right. That's a slightly better example than just telling them to type in a 3, right? That's more real world. So basically the syntax is priming read, and then while invalid, your expression is, something invalid, then produce error message and then ask them again. That's the general syntax. General syntax for input validation. Priming read, and then if invalid, I don't know why I'm just putting all this in a comment when I could use a multi-line comment. Then display error, and then read again. Or if you're going to write it in one of the other ways, right? But now I'm real curious as to how the book's going to show it. Be real interested to hit the PowerPoint. Let's find out. Yep. Read an input. While the data is invalid, display the error message, read it again. So that's the general approach. That's what they are recommending. The priming read method, even if they're not calling it that. That's what the fundamentals textbook did. Read the first value. Is it invalid? Yeah. Error message. Read it in again. Counters. Well, there are definite loops and there are indefinite loops. A counter is a definite loop. What do I mean by that? You know where it's going to start, you know where it's going to end. So a counter just starts at some value, ends at some value, and it increments or decrements each time the loop repeats. So you have a loop control variable, and it gets incremented or decremented each time. And it has to be initialized before entering the loop. So for example, we're going to write a loop that counts from 1 to 10. Let's make a new variable. I'm tired of x. Int c for counter is equal to 1. While, parentheses, c is less than or equal to 10, in parentheses. Oh, I'm going to mess with this just for a minute. I'm taking the braces out so I can do this. C out, less than, C, less than, ENDL, semicolon, but I'm going to make that C out C++. I'm probably going to revise it to do the way that I normally do it. You'll see a lot of programmers, especially C programmers for some reason, who like to do it like that. What are we doing? We're combining the incrementing and the processing in one statement. Now I think that's a little bit too clever by half. I don't see any advantage to doing that except it saves one line of code, but it doesn't run any faster. So I would recommend doing it like this, like I was going to go to begin with. At least until you decide you want to start getting fancy. Let's walk before we run. So in this class you'll never see me do that. You'll never see me handle the value for output while I'm incrementing it. I like for the update to be the very last thing in the thread, in the block of code. So it's a counting loop. So this is a counter loop. This is your loop control variable. Initialize loop control variable. The next one is test the loop control variable. And then process, and then update loop control variable. So you have kind of three things going on there. I can line them all up. If I feel like wasting my time, I could do that. Right, line up all my comments. So four things going on. Initializing the loop control variable, testing it in the while expression. In the body of the code, we do some process and we update the loop control variable. So a counter loop is what some textbooks call a definite loop, because the number of iterations are known in advance, or at least its behavior is consistent. You know, whatever starting point it is, whatever end point it is, it's just going to run all the way through them. Well, the fact that there's a definite loop also means that there's an indefinite loop. What about these things where we told them to enter 5? We don't know whether they were going to get it right the first time or whether they were going to be stupid and type in 3 5,000 times in a row. So that's an indefinite loop. An indefinite loop is one where there's no way to predict how many times it's going to repeat. We don't know in advance whether the user is going to type in, you know, one value and get it right the first time, or they're going to keep entering the wrong value. Another example of an indefinite loop is when you're reading input, right? When you're reading input from a file, you might not know whether the file is going to be one line of code or one line of data or 1,000 lines of data, right? One record or 1,000. So it could be that it's going to be coded as an indefinite loop. While not in the file, keep going. Now there's another way to code it that makes it look like a definite loop. But anyways, we'll get to that when we hit file IO. So a counter is a definite loop. The iterations are known in advance. There are also indefinite loops, where the iterations are not known in advance. code might loop once or a zillion times, depending on the input. And I'm not going to add any examples of those because all of our loops up there, except for this counter, all of the prior loops except the counter loop are indefinite loops because we don't know in advance what the user is going to type, what the user will type, and how many times it will repeat. Fix my grammar a little, since some people are still typing. All right. There's a shortcut for doing a counter-based loop. Up here, we have a counter-based loop, and it took like 5 lines of code to write. We could write it in 2 lines of code if we wanted to. It's probably going to be a little bit more than that because we're going to want to use the closing braces. But we have 4 steps here. We have initialize, we have the test, we have the process, and we have the update. So we have step 1, step 2, step 3, and step 4. But the for loop lets you combine step 1, step 3, and step 4 into a single line of code. So we're going to write another loop that counts from 1 to 10 using a for loop. Now in Python it would look like this. For x in range 1, 11, incrementing by 1s. Right? That would count from 1 to 10. Nah, we're doing C. So let's do for int d4 parentheses, int d is equal to 0, no, 1, we want to count from 1 to 10, semicolon. Keep running while d is less than or equal to 10, so d less than equal to 10, semicolon, d plus plus, or plus plus d, right? I can't help it, I like seeing d plus plus better. And then inside it, we could print it out. C out, less than d, less than e and d out. There. So what took us 4 lines of code, 5 lines of code, at least 3 lines of code counting if you left off the braces, which you're not able to do up here because our block of code had 2 statements in it, we were able to accomplish in 2 lines here. Much more succinct. Why? Because steps 1, 2, and 4 are all done in the header here. Steps 1, 2, and 4, the assignment, the test, and the update are all specified in the for statement, the for header. Much more succinct. If you're writing a counter loop, I would just default to always using a for loop unless you have a really strong reason to do something else. If it's a definite loop, you're probably going to use a for loop. And when we get back to the PowerPoint, we'll see that. So here we're initializing our variable. Num is equal to min number. And then we have a test while the number is less than equal to the max number. We have a body, which is print out something. And then we increment. We update. So the do while loop. Fortunately, I've already talked about it. We could just skip this slide, but we'll mention it anyways. The general format is do the statement or block while expression, semicolon. So functionally, it's like this. Do some statements, then we have the expression, and if that expression is true, it repeats. So you can see why it's post-test. The statements are performed first, the body is performed first, and then the test is done with the while statement after the end of the block. Yeah, we've already talked about that. Even if the test expression is false, this line of code will always execute at least one time because it's a post-test loop. There's nothing preventing it from getting to this point. Here they say, this is useful in menu-driven programs to bring the user back to the menu to make another choice. I'm not sure if I see any reason that menu-driven programs need to be implemented with do loops more than while loops. And as I've already stated, there's nothing you can do with a do loop that you cannot do with a while loop. So I'm not going to say, yeah, if it's a menu-driven program, you should always do a do loop. Just pick which one makes the code cleaner in your eyes. The for loop, very useful for counter-controlled loops. For initialization, that was the first thing. For x equals 0, do the test, x less than or equal to 9, update. And then the statement or block. Better not put a semicolon here. If you put a semicolon here, it'll rip through this entire thing, iterating through every possible value, and then it's going to just do this one time. Why? Because if you put a semicolon there, it's the same thing as if you had a little block of code there. And then this happens no matter what. So just like you have a while or an if you have a for there, better not put a semicolon there. So it performs the initialization. It enters the body of code. No, it performs the initialization. It's a weird sequence of events. Initialize, do the test, do the block of code, and then do the update. So that kind of makes sense because it's got to initialize it, it's got to test it, but it's not going to update it before it does the block. It updates it after it does the block. So that's kind of the odd thing about the syntax, is that, you know, that happens first, that happens second, but this doesn't happen until after the entire body is executed. Now, if you think about that too much, it hurts your brain, but I think that intuitively, you already got it if you look at it like this, right? That makes sense. Set it equal to that, do the comparison. If that's true, it's going to run this, and then when that's done, it comes up and adds one to it, and it checks again. If you set it up so that the expression is false, it won't do it because it's a pretest loop. So if we said for count equals 10, for count equals 19, just because that's what I typed, keep going while counter is less than or equal to 5. Well, it's not, so it won't even enter the body, just like a while loop. It's a pretest loop. So if the initial condition is incorrect, is false, it won't enter it. Now, the strange thing about for loops is that you can leave off any part of the syntax. You can just delete that. Well, counter had better been set to something before that happens, right? But you're allowed to leave that off, and then in which case there's no initialization step. We're saying, okay, the value was initialized previously.
Does it still require the...
It does still require the semicolon now. Yep. You can leave that off. If you're going to encode the update in the block, now why would you do that? Because now it's just a while loop. But you can do that. But come on, stretch. Anyways, that's perfectly good syntax. At that point, it's just a while loop. You can even take this out. Now we're getting a little bit moronic. And then if, count is equal, or count is greater than 5, then break. Right. Now, there's absolutely no reason to write that. Right. If you ever see 4 like that, it looks like some emoticon of a crying person or something. I don't know, or a walrus or whatever. There's no reason to write that. Right. In my mind. Maybe there is. But if you're going to do that, you may as well just make it a while true loop. Because that's what it is. Just keep repeating. So if you leave this middle clause off, if I undo all this stuff, apparently it's not going to let me undo that last step. Right. If you leave this middle clause off, it assumes it's true, which is kind of strange in my mind. But if you leave that out, it still assumes it's true and it goes in and it enters the code. But there better be an if and a break in there, or else it's an infinite loop. So let's write something that'll do something like that. Print out all the numbers and then their squares. Using a for loop, because for loops are so dang awesome. I'm going to come up here, and so that we don't have to enter all that stuff each and every time we run it, I'm going to make it the first thing that happens under main. So cout quote x \t x ** 2, x and it's squared, \n, end quote. I'm using a tab here. Now I'm going to have my for loop. For int x is equal to 0, x is less than 10, or how about less than or equal to 10, x plus plus. Now one thing to notice is that you can declare your variable right there, but you don't have to. But if you do not declare your variable inside the for loop's header, you better have done so up above. And that's what the textbook is showing. If we go back and look here, they initialize their variable outside of the for loop syntax, but you don't have to. I'd rather not. I'd rather put this. To me, the advantage of that is that it uses this variable and then it cleans that variable up, and that variable no longer exists by the time you get out of the loop. If you need to test that variable or do something with it after the loop, then you can't do that. If we needed count by the time we were down here, then we would have to do it, leave it the way that it was. Have to, create it beforehand. And then it would not have fallen out of scope by the time we get to that point. Back over here. All right. So, for parentheses, int x equals 0, semicolon, x less than equal 10, semicolon, x plus plus, close parentheses. Let's write out x and x to the power of 2. Cout, arrow x, arrow, double quote, \t, and double quote, arrow x times x, or we could use a POW function, arrow ENDL. So that'll make our little table of squares. If I asked you how many times this is going to iterate, how many lines of output we're going to see, not including the header, how many times will the loop iterate? Somebody be very brave and bold and make a guess even if it's wrong. Is it going to iterate 10 times, true or false? Right, the answer is false. It's not going to iterate 10 times. Why? Because it's starting at 0 and going up to 10, up to and including 10. Well, if we were going to start counting on our fingers and hit 10, we'd probably start at 1 and get up to 10, and we've used up 10 fingers. So that starting at 0 means that we're actually doing 11. If we changed it like this, start at 0 and keep going while less than 10, now it's going to print it out 10 times. I'm going to leave that off. And there we go. Here's our little table of squares. Is there anything you can do with a for loop that you cannot do with a while loop? Absolutely not. I say that, but that's not strictly true, but that's because that's using what's known as a range-based for loop or for each loop. But for a classic for loop, that syntax, there's nothing you could do with that you can't do with a while. So really, while loops handle everything if you want them to. You don't have to have the do loops. You don't have to have post test. You don't have to have fors. You can do it all with whiles. But the syntaxes are specialized to make them easier to understand. More succinct. This is nice because you see the starting value, you see the end value, and you see the update in one fell swoop. Your eyes look at that, and within a second, you understand what it's doing. Okay, so when to use each kind of loop. Let's add that to our notes. We're just going to write some recommendations. I might go ahead and put this way down at the bottom again, above my pause. Guidelines for loops. If it's a counter-based loop, use a for loop. Just always. If the body must be executed at least one time, always use a do loop. Pretest, post test, use a do loop. Post test loop. Otherwise, use a while loop. So if it's a definite loop, you'll probably be doing a counter. Now you can kind of misuse the for loop syntax to do indefinite loops as well. But I'm going to kind of ignore that. Some people just love the for loop header, and so they try to cram all sorts of loops into it. And you can, but again, why not just pick a tool that makes more sense? So when you use a for loop, in any situation that requires an initialization, a false condition to stop the loop, and an update to occur at the end of each iteration. Now that's a little bit more broadly worded than a counter loop. It's about the same though. The only thing is that you could get weird and put your CIN statement right there as your update. I would never do this, but you could do something like this. I'm gonna delete it. For int x is equal to 0, keep going while x is less than 10, and the update is going to be CIN into x. Right. Now it's an indefinite loop, because if they typed in 20, then it would exit the loop. No, I would not do that. What if you need to do more than one initialization step? What if you want to set both x and y equal to 0? Well, you could do that, but you better declare those variables beforehand. So something like this. I'm just going to call them a and b. Int a comma b. For parentheses a equals 10, comma b equals 100, semicolon. That's our initialization step. And then keep running while a is less than or equal to b, semicolon. And what's our update going to be? A is going to start counting up and B is going to count down. A plus plus, comma, B minus minus. And if you're thinking that that's kind of weird compared to the way Python did for loops, you're absolutely right. It's not weird. It's just it's considerably more flexible. The initialization step doesn't just have to be one line of code. You could do 20, 30 things all separated by commas. The only thing you can't do is like have the word int there and the int word there. Okay, I could be wrong. Is that going to work? Well, blow me down. Okay, fine. That works. Neat. Let's compile it and make sure that it actually works. No, I did get an error out of it. Okay, it did not work, even though it wasn't underlining anything in red. If you're going to initialize more than one thing in your for loop header, they need to be initialized beforehand. Or at least one of them had better be. Okay. And then, I don't know, let's print out A and B, just to watch one of them count up while the other one's counting down. So cout less than A, less than, quote, backslash T, end quote, less than B, less than ENDL. We'll see one of them increasing, the other one decreasing, and at the point where they cross, when A is no longer less than B, it's going to exit. Oh, but I have that at the bottom of my code, or why did I not see it do anything? Yeah, this is at the bottom, so I have to answer all three of my little questions before it'll do it. All four of them, excuse me. But you see it counting up. 10, 11, 12. X continues to increment while A continues to increment while B decrements. And when A is no longer less than B, it stops. So if you have multiple steps there, you separate them with commas. If you have multiple steps there, you separate them with commas. Can we separate things with commas here? Like, could we make it exit if A was no longer less than 10? Can I put a comma here and then say A has to be less than 10? No, less than 20, because it started off as 10. I think that's a syntax error, but let's find out. Well, what do you know? It counted until X was less than 20. So you can even chain conditions there with commas. I did not know that. What I would have done is I would have put an and there. Right? To me, that makes more sense. Keep running while A is less than B and A is less than 20. Right? To me, that makes sense, but feel like being like that? Feel like being obstinate and strange and obtuse? You could do it that way. I'm going to get rid of that, though. It bugs me. So for is a pretest loop. I've mentioned that a couple of times. You can put in two initializers separated by commas or more. You could chain 100 in there. You could chain multiple updates. And they don't mention that you can chain the conditions. I wonder if that's a feature they added to the language. If it wouldn't work in straight C. I don't know. Or in Java. You can omit the initialization step. You just put a semicolon. You can declare variables in the initialization step, which I have been doing for the most part, right? For int x equals 0, x, you know. Keeping a running total. Running total is something, you know, that is continuing to hold all the values that are entered into it, that it passes through. Like you're adding up test scores, or you're going to add up all the numbers between 1 and 10, or you're going to calculate the factorial, which is all the numbers multiplied in sequence between 1 and 20. 1 times 2 times 3 times 4. You need to keep a running total, which means that you need an accumulator variable that's declared outside of the loop and above it, and then inside of the loop you modify it. So you have an accumulator variable that holds the running total, and it better be declared above the loop. And then inside the loop you can update it, right? Sum is plus equal to number, so this is going to add up all the numbers between 1 and 10 inclusive. Set our accumulator to 0. Is there a number to read? Yeah, read the number and add it. Now when they say read the number, it's like they're asking the user to type something in instead of just running it automatically here. This is a definite loop, right? Absolutely a definite loop, so it could have been implemented as a for loop. So why not? Let's go and implement it as a for loop. We're going to create the sum. We're going to calculate the sum of all the numbers between 1 and 10. Better create our sum variable. Now if I'm going to be calculating average, I always declare my sum as a floating point value, just so I don't have to cast it later or anything like that. But I'm not going to calculate the average, so why not? Int sum equals 0. For parentheses, int space value equals 0. Why not start it at 1? For int value equals 1, it wouldn't matter though if it was set to 0, right? Because 0 plus 0 is still 0. For int equals 1 semicolon, int value equals 1. Keep going while value is less than or equal to 10 semicolon. Add 1 to value each time, so value plus plus. And then inside the curly braces, sum equals sum plus value. Or if you want to show your mastery over the language, sum plus equals value. So this is example of keeping a running tally. And since it's a definite loop, I used a for loop. Didn't have to. There's nothing you can do with a for loop that you can't do with a while. I think I've almost... So what is a sentinel value? It's a value that forces the data to stop, to exit the loop. Please enter score or -1 to quit. Well, that -1 stops it. Please enter name or period to quit. That period stops it. So a sentinel value is an invalid piece of data, or a value that has no meaning for what you're asking for, that serves as a stop condition. And what do I mean by invalid? You can't say enter test score or 100 to exit if 100 is a valid test score, right? You would want to make them type in something that's invalid. Now, if you say enter test score or -1 to exit, -1 had better be an invalid value. Your prophet better not be such a jerk he can give you a -1 on your exam. So a sentinel value is one that's in a list of values that indicates the end of data. It's a special value that cannot possibly be confused with a valid value, like -999 for a test score. To me, -1 is enough, but okay. Yeah, I mean, it could be as silly as you wanted to make it. Right? Oh, come on. But you get the idea, right? Something that would cause it to stop. And you use that for indefinite loops. Used to terminate the input when the user may not know how many values will be entered. And I am going to stop there. We will hit sentinel values again on our next lecture. What's that problem? It should actually be 1173, but whatever. Homework is 5 parts, A through F. You can put them all in the same CPP file as you want. What you're going to do, ask the user for the number of rows and the number of columns, and then print out a rectangle of that many rows and columns using asterisks. I'm not liking this homework assignment. That's requiring nested loops, which we haven't talked about. All right, counting from 0 to 500 by 50s is kind of valid. I'm not liking that, and I don't know why it's not letting me get out of protected mode. All right. I'm going to save this one for another day. We don't need to create nested loops. Okay. So write a program that will sum the calculation, the summation of all the values between 1 and a value the user specifies. So if the user says 6, we're going to add up all the values 1, 2, 3, 4, 5, 6. If the user enters 2 billion, we're going to add up all the numbers between the summation 1 to 2 billion. Next, write a for loop that will count from 0 to 500 by 50s. And then ask the user how old they are and then print happy birthday that many times. So if they're 37, we're going to print happy birthday 37 times. Now don't specify whether you have to use a while or do a for loop, so just please yourself. Ask the user to enter 10 values. For each number entered, print positive. If the number is negative, I don't want that one either. I don't know. Why not? Let's leave that one in. Okay. Ask the user to enter 10 values. For every one entered, print positive if the number is greater than 0, negative if it's less than 0, or 0 if it is 0. So please enter 10 values. Enter a value, 6. It's positive. Enter another value, negative 3. It's negative. Enter a value, 0. The number is 0. And so on. You know, keeps going for 10 iterations. That makes sense, guys? I bet y'all could do the nested loop just as well, but yeah, we'll save it. Any questions? My brain is fried. I'm ready to stop. I don't know about y'all. All right, just stop there. Let's make a Dropbox.